This number 27 is pretty straightforward with Desmos, but I do want to show you how to do it other ways by hand. Not because we need to for this problem, I absolutely would just use Desmos, but because it allows us to gain fluidity and flexibility with the vertex form and with understanding the vertex, which can be helpful in other questions. So we'll use this as a review of the vertex form and the vertex of a parabola and all that good stuff. But first, how do we do this just to get the answer? Let's just graph this. So x minus 2. X plus 15. And the question is asking for what value of x does it reach its minimum? So here's the minimum value of the function. The x value of that minimum is negative 6.5. And so the answer is negative 6.5. So, okay, cool. Move on. But what can we learn from this question? Well, let's just say we didn't have Desmos. What would we do to solve this? The key on this problem is this word minimum. Whenever we're dealing with a quadratic, as we are here, and it says something about the minimum value, the maximum value, or any word like that of a quadratic, we should be thinking vertex. So really the goal on this problem, as we saw with Desmos, is to find the vertex of this quadratic. There's really, I'd say, 3 separate ways of doing this. Which way should we do first? Let's do the long way first, then the medium way, and then the fast way. So the long way is going to be, let's FOIL this out. So f of x will be x squared plus 13x minus 30. And then what we're going to do is complete the square, right? If we complete the square, this will put it into the vertex form. And then we'll find the vertex. And then in this case, we want the x value of the vertex because we want the value of x for which this reaches its minimum. And then we're good to go. So how do we complete the square? We take this value next to the x, this b value. We divide it by 2 and square it. And then normally with a circle, we would add it to both sides, but I'm going to do a little bit of a wrinkle on this problem, as you'll see in a minute, since it's a quadratic. Anyway, it's 13 divided by 2 squared, which is very sad because this is an annoying fraction. So let's just leave this as a fraction for now. Let's leave this as a fraction. So this would be 169 over 4 when I square the 13 and the 2. So what I'm going to do is I'm going to take that 169 over 4. I'm going to add it right here. But I need to balance that. I can't just add something randomly to my equation. So I could add that to the other side. But what I'm going to do here, because it's going to help when I build my vertex form, is I'm just going to immediately subtract it from the same side, right? I'm going to add the 169 over 4, and I'm going to subtract the 169 over 4. And the overall change here is no change, right? These just cancel, and we would get back the original. Why am I doing this? Well, notice what happens next. If I FOIL this, factor this, what am I going to get? A little bit of a trick here with the completing the square. Whatever you got in here when you did this b over 2 thing, when you go ahead and factor this, you're just going to get whatever is in the parenthesis over here when you factor this and get this x plus 13 halves squared. So yeah, you could try to factor this by hand. It's just kind of annoying to think through. 2 numbers that multiply to 169 over 4 and add up to 13. They've got to be the same number, but luckily you already know it. You can just look at whatever you had figured out previously. So that's cool. And then over here, it's going to be minus 30 minus 169 over 4. 30 is just negative 120 over 4. So if I do minus 120 over 4 minus 169 over 4, I should get minus 289 over 4. Now, we don't actually care much about this value. For this problem, we only cared about the x value of the vertex. And since the vertex form is x minus h squared plus k, this h, this minus h, has got to be equal to 13 halves, which means h is negative 13 halves. Be careful with that sign, right? If the equation is x minus h squared, then when I plug in negative 13 halves here, it'll be x minus negative 13 halves, right? You can think of it as just literally this. X minus parentheses negative 13 halves squared. And that tells us that h is negative 13 halves, which is the same thing as negative 6.5. So we get the same thing. Now, negative 289 over 4, that should match the y value of our vertex, assuming we did all the arithmetic right. So negative 72.75, does that match? Let's see. Yeah, negative 72.25. Okay, so negative 72.25, that's good. And that matches this if we needed it. But in this case, we just wanted the x value. So that's the kind of long way. What's the medium way? Well, let's go back to when we had the quadratic. So f of x is equal to x squared plus 13x minus 30. And all we need to do here is just find the value of the axis of symmetry, which is negative b over 2a. right? Negative b over 2a, using these values of a and b, so 1 and 13, will give me, if I have a parabola here, it gives me the x value of this axis of symmetry, which is the h value of the vertex. So I can kind of skip everything I did here and just use this. And if you think about it, this actually just makes sense with what we did here. Like, it makes sense that this was important to our answer, because remember we did that 13 halves thing, and that ended up here. And I do see this 13 divided by 2, which I see here is 13 divided by 2. So it all kind of fits together one way or the other. But long story short, b is 13, a is 1. So we get negative 13 over 2, which is negative 13 over 2, which is negative 6.5, same thing. Now, that's the medium way. What's the fastest way? The fastest way is to recognize that I have this quadratic here. Let's go back to the beginning. F of x is equal to x minus 2, x plus 15. If I were to graph this quadratic, we would know, given this factored form, if I were to set this equal to 0, we would get two solutions, 2 and negative 15. So I know my parabola would look something like this, right, where it hits the x-axis at 2, 0, and negative 15, 0. And the trick is that ultimately the axis of symmetry, or the h value of the vertex, has to be equidistant from these 2 points, right? Based on the symmetry of this parabola. If these 2 points are at this kind of equal height of 0, then the x value that's equidistant from them must be that dividing line that cuts it in half. So if I simply do negative 15 plus 2 divided by 2, if I average the x-intercepts, what do I get? Well, I get negative 13 over 2, which is the answer. And again, this should be the line x equals negative 13 over 2, which is the h value of the vertex. So this, again, the 3 ways we did it here outside of Desmos we don't need for this problem, but these are 3 tools that you may find useful in other problems where Desmos is less viable. For example, this is a nice little shortcut that helps in a lot of harder quadratics problems. You can learn something about that quadratic that you didn't think you knew on first glance. In this case, that x value of the vertex. Using negative b over 2a is very important on certain questions, especially those involving constants and quadratics. Of the 3 random techniques here, the complete the square approach, probably not needed for quadratics on this test, but it actually does kind of show you the links between these. In some ways, these 3 methods are all the same. They're just different views of the same totality, the same whole, right? Different approaches to the same kind of underlying structure, the same underlying math. So, but again, they kind of all give you a different approach, a different way into the problem. If you know how to do all these methods in addition to Desmos, it just makes you a much better problem solver, much more flexible, much more adaptable. If you're having problems on those hard questions, you're probably just too rigid, you're too brittle. You know this way and that way, but if you know the variety of methods and tools at your disposal, it'll make you just solve these problems much more quickly and much more easily. So yeah, this one is negative 6.5.